Today we're going to explore the quadratic in factored form. So remember we talked about the three different types of quadratics. So we have the standard form, we have the vertex form, which we covered in the first unit, and then right now we're talking about the factored form. Okay? So let's look at, so we have the equation here, y equals to x plus 2, bracket x plus 1. So let's look at the graph. So this is the graph of it. Which way does it open?
Upward.
Open outwards, right? And there is a reason why it's opening upwards, right? What's the A value here? Can you guys remember, do you remember, or do you know what the A value is? What is it? 1, right? It's right here that you can't, it's an invisible 1, right? It's a positive value. So because it's a positive value, it's going to open up. Good. Now looking at this graph, I know it's not very, very clear, but looking at this graph, can you tell me what your zeros are?
0 minus 2.
Negative 2 and?
0.
Negative 2 and? What's the other one?
Negative 1.
And negative 1, yep. So it's right here, right? And right here. So the two zeros are negative 2 and negative 1, right? And I told you can write them in two ways. So you can write it as x-intercept equal to negative 2 and negative 1. Or you can write them as a point and write it like so. All right, now can you see where the y-intercept is? It's almost, yeah, we're going to say it's 0, 2. It is almost actually. Okay, so the y-intercept, let's say it's going to be at 0, 2. Another way that you can write it, you can say y-intercept equals 2. Okay, so you have a choice of how you want to write it. Where's your vertex here? So it's between negative 1 and negative 2. So it's at negative 1.5. Okay? And if this is negative 1, this looks like it's a quarter or negative a quarter, right? So I'm going to say that the vertex is at negative 1.5. And negative 0.25. How about your axis of symmetry? Negative 1.5. So the axis of symmetry is gonna run right here, right? Which is through the vertex. So it's gonna be x equals to negative 1.5. And what's your optimal value? Negative 0.25. That's the y value of your vertex, so y equals to negative 0.25. Can you tell me if it's a max or a min? It's a min. It's a min, right? Because if you look at it right here, that's the minimum value that you can have. Everything else is higher than it. All right. Okay, let's look at the second one. So I have a quadratic function. Which way does it open?
Upward.
Downward. Right, downward. And the equation is negative 2 bracket x plus 3 x minus 1. Does it make sense that it's opening downward? Yes, because your a value is negative. Good. So what are your zeros? 1 and negative 3. So I can write x-intercept equals 1 and negative 3, or I can write it as 1 comma 0 and negative 3 comma 0. Where's your y-intercept? At 6, that's right. So 0, 6. So I can write it as y-intercept equals to 6, or I can write it as 0, 6. All right, and your vertex? It's at negative 1 and 8, yeah. Guys, remember that the way you write things is very important. It's like, writing a sentence with the commas, with the periods, with the question mark, right? It's the same thing. When I put up parentheses, I mean to put that parentheses there, right? I'm not just putting them for decoration. We need it, okay? Because that means it's a point, and a point has parentheses and has comma in the middle between the two values. All right, what's your axis of C? So x equals okay. And what is your optimal value? Y equals 8. Good. So now I want you to take a look at the values that we just wrote in this table and take a look at the equations that we have for these graphs. And tell me if there's any connection between the values that we have came out with and that equation. Do you see any values like that you see in the equation and in the table of values?
Minus 1.
Minus 1.
Minus 3.
So you're talking about these values right here? Okay, what do they match? They match the zeros? Yeah, but what's the difference between them and the zeros? They're the opposite sign, right? Okay. So you're saying that this is 3, but here it's a negative 3. And this is a minus 1, but here it's a 1. Right? So these are matching the x-intercept or my zeros. Right? But they're the opposite of that. That is exactly what you can find from the factored form. So from the factored form, I can find my zeros. Okay? What can I find from the vertex form? The vertex, right? Which is the axis of symmetry and the optimal value. From the factored form, I can find the zeros. Other words, we have for zeros, we have x-intercept, right? Some of them, they call them roots, right? Some would call them solution, right? So there's different names that means the same thing. Are we okay with that? All right. So an equation in factored form, so that it's going to look like this. location of the x-intercepts, or the zeros. So, the zeros must be removed from the brackets, which means, can you look at me? So, what you do, you take each bracket and you set it equal to 0. So I'm going to set x minus s equal to 0. To solve for x, I'll just bring the minus s over and it becomes a plus s. So if I had x plus 1 and x plus 2, or minus 2, let's put it, okay? I take my bracket and I set it equal to 0. I should write this right here because I gave exactly the same equation. Okay? So I take my bracket and I set it equal to 0. And then I isolate for x. To isolate for x, what do I need to do? Move the 1 to the other side. And when I do that, it becomes a negative 1. Okay? Remember, they're called the zeros for a reason because we take them and we set them equal to 0. Then I bring this over and it gives me x equals to 2. So my two zeros are minus 1 and 2. Okay? So when it's in factored form, you want to find the zeros, you take each bracket, set it equal to 0, and solve for x. Okay. Now, my question to you is the following. If I want to go from factored form to standard form, what do I do? So if I want to go from this form to this form.
New form.
That's right. So both of you said the two key words. Expand, that's the process. FOIL is the method. Okay? So we can be converted to standard form by expanding. And in this case, I'm going to use FOIL. Okay? So let's do that. What's the first thing I want to do? Multiply the brackets together, right? So x times x gives me x squared, x times 1, 1x or x, minus 2 times x, and minus 2 times 1 is negative 2. Then there's two steps that I still need to do. I can simplify inside my brackets first, collect like terms. So you see that the like terms are the 1x and the minus 2x. And then my final product, my final thing is multiplying, distributing that 3 in. So it's going to be 3x squared minus 3x minus 6. So I converted from factored form to standard form. Do you notice that the a value is still the same? Right? The a value is still the same. Now what can you find from the standard form? The y-intercept, right? The y-intercept, which is, what is it? Negative 6, right? So that is the y-intercept. So here is a recap. Factored form, I can find the zeros. Standard form, I can find the y-intercept. And vertex form, I can find the vertex and then the axis of symmetry and the optimal value, which is part of the vertex. So each form is useful for something. Okay? That's why they have the three different forms. We okay with this? All right. Now, if the question is asking you to solve, if it's asking you to find the zeros or to solve or to find the x-intercept, what form do I need to put it in? The x-intercept or to solve. I have to put it in factors form. And what did we learn yesterday to do? Yesterday we learned to do what? Or the day before yesterday? Sum and product. Difference of squares. Common factor. These are the way to factor, right? So if I want to go from the standard form to the factor form, I have to use these three methods. These three methods. Okay? What's the first thing I always ask myself? Do I have a common factor? Do I? In this case, y equals negative 3x squared plus 24x minus 48. Do I have a common factor? 3. Negative 3, right? Because that 3 has a negative in front of it. You don't want it there. So you want to factor it out. So if I factor out the negative 3, I'm going to end up with dividing everything by negative 3. I'll end up with this. What would be my next step?
Perfect square. No.
Do I have a binomial or a trinomial?
Try.
So what method do I have to do? Sum and product. So I'm looking for two numbers that multiply to and add to. Because B is negative and C is positive, that means I'm going to have to do both negative, right? So both my factors are negative. Okay, give me numbers that multiply to 16. 8 and 2. Both are negative. It adds to negative 10. Negative 4 and negative 4, what does it add to? Negative 8. Is that my answer that I'm looking for? So that means this is my solution, right? These are the factors that I'm going to use, the negative 4, negative 4. All right? So, just now a matter of writing y equals negative 3, open bracket, x minus 4, x minus 4. Okay? Now I'm not done yet because the question is asking me to find the zeros, right? What would be my zeros? How do I do that?
Make x minus 4 equal 0.
That's right. So set each bracket equal to 0.
And then bring over the 4.
Bring over the negative 4. What does it become?
Positive 4.
Right? If I do it again for this one, what is it going to give me? So it's the same 0, right? So in this case, this is one of the cases where I only have one 0. So with quadratic, you can have, did I explain that to you before? That with quadratic, you can have two zeros, right? You can have no zeros. In this case, I have no zeros. Or you can have 1, 0. And that's the case where your vertex is actually your 0 at the same time. Okay? So these are the only 3 cases that you're going to have with quadratics. Either you're going to get 2 zeros, 2 different values. You're going to get no zeros, which is we're not going to explore. Well, actually, if you can't factor, then you have no. Yes, you will. Never mind. Just do not. Just erase that. If you can't factor, it doesn't mean you don't have zeros. It means that your zeros are not full numbers, But there's cases where we don't have zeros, okay? And there's cases where we're going to have 1, 0, which is this case. Okay? So I'm going to stop this for a second. I want you to do B and try C, and then I'm going to take it back.